Hello guys, welcome to my video. Today I will show you one of my favorite words that I have made, my command line interface. Alright, I will display you how this works and what is that advantage. A command line interface is an interface that allows you to use any informatic system using command entries. The Windows PowerShell and your favorite terminal on Linux are examples of that one. But can we do that one in MCU? Yes, of course. I made a library to do this possible. You only need your favorite MCU. You need only to know how to program in C++ and a command list for set to your embedded system. By example, we have this professional sensor. That sensor has inside a MCU. You send the data using external communication protocol. I personally use this weather station. You type the command get weather. The weather sensor returns you the weather conditions. And this is better that it just send a character and you return the temperature. What that means? This is the thing. This is the important thing of this interface. You can convert your embedded system in one of these professional sensors. Let's see how to do that. I have one of my favorites MCU here, the SP32. I like this guy because it has too many characteristics, interesting characteristics as a Wi-Fi sensors, many things. Alright. I have also a real-time clock calendar, a DS3231. I have a BMA280 weather sensor. I have also two LEDs, one red and green. I have a SD card module and a servo motor. And also I have an external power source for my servo motor. I have this SD card but future videos. In today's video I won't use this. Now, the objective of this is demonstrate this interface. That means that I will send a command to the USB to serial converter of this MCU. In this case is the external communication interface. Then I must be able to read the date and all the information of the DS3231 of the clock calendar. I must be able to read the weather information. Also, I need to turn on and turn off each LED individually and setting the angular position of this servo motor. I must do all of this using the command line interface. Alright, for this one, I am using I am coding this one using Visual Micro on Visual Studio Code, and I am sending the data using the embedded serial terminal for sending the data. And this is the code that we will use for explain this. I made this code and I'm using my libraries. And I am using Adafruit libraries for getting the weather information of my BMA280. I am using this library that I made by myself for getting the data of my real-time clock calendar. And I am using also the servo library for setting the servo position. This is my command line interface libraries that are necessary for make this one. You need a CLI buffer module, CLI command, and CLI parameters for make this. This is only a variable instantiation or setup function and or loop function. Usually on embedded system you can use loop or you can use while one. I am adding two no printable ASCII characters at the end of the sentence because this is the indicator that the command entry. All the command line interface must have this. Alright? So we need to start this instantiation properly for work. For make this one, we need to set the buffer module where our command will be cached by our communication interfaces. We need to start a buffer instance, my buffer. We need to set using the separator character between the command and parameters. In this case, we are using the space as the character. And we need to indicate the two termination characters for the buffer. Then you need to create each command using this the CLI command module. We need 4 commands. Get time will retrieve you the time information of the real-time clock calendar. Get weather will retrieve the weather information. And we have 2 more commands with data. We need to must be able to set the servo motor position. We need to indicate the angular position. Then we need to set the parameters of that command. Also, we need to be able to turn LEDs. We need the command turn LED or turn each one of them. In this case, I am adding also the parameters to the parameters command. In this case, we have the set servo command, and we need to add the angle parameter as an integer because we need a data type. The parameter supports the most common data types as an integer, string, boolean, and also the floating point parameters. We need to use the turn LED command, and we need to add the next parameters. We need to specify the LED color and the status of the LED if it is on off. All right. Then we need to start the servo and all the rest of the variables. The loop function is the function that will be executed forever and ever. Then in this function, we are continuously reading the input serial communication for this microcontroller. Each time that we have a new character on buffer, we catch that character and we send to this function. This function is the function to manage all the commands. So let's go to process command function. That function manage all the command entries that arise to our buffer. Also, I am using these 2 auxiliary functions to display to the user and the error message. And in this case, this function displays the command name and the error code. And also, this one converts the error code number to a message to understand to the user. Yes, my library supports the error management because it has a common error codes in the command. First, we need to add an input character from our external communication interface to our buffer. In this case, we use this function to add the character to the buffer. After this one, we must ask to the buffer if a command line interface of click enter was happened. In this case, if happens, we need to check that the buffer has not error. In this, the errors could be any user error, but if there are not error, then we can ask for each command. We need to ask by the get time command using the buffer. We can we also ask about get weather, set servo, and turn LED commands. Each command looking into the buffer. Also, we have a default command management. If an unknown command was typed, we must display to the user the proper message. Please be gently with the user. All right. So now I will explain you how this works. If you have a command entry, then you need to check if the command has not error. If the command has not error, you make these routines for each command. In this case, for get time, we display the time using this function. This function is defined in a helper script that I made. All right. If there are an error, and then you must display this one to the user. After that one, we do the same with get weather. If the get weather command occurs, we need to send this information to the user. This is the reason because I like this sensor, because you can read too many temperature parameters with just one sensor. These 2 first commands are queries. That means that you only will retrieve the information of the sensor. But what happens with the parameter command when we must have a parameter? So in this case, in the set servo, we have the parameter angle. After we check that the command has the proper information, after that you check that the command has not error or type error, you need to ask by the parameter name. In this case, the parameter name is angle, and if the parameter exists, you take the parameter using the function getInt. In that case, we'll extract the integer of the parameter this parameter. You need to specify the parameter name. This position must be between the limits of 0 and 180 for this servo motor. Alright, if this not happen, the proper message will display to the user. Also, we do the same with turn LED command. This command has two parameters, color and on-off. We need to ask first that the parameters exist, and then we extract the parameter using the get pole, because we need the Boolean value for turn on and turn off the LED. Alright? So now let's test the command using our command line interface. Let's start with get time. Look, we have the information of the DS3231 or real-time clock calendar. We have the alarms, the time, the oscillator status. Oh, nice. This is the reason because many people like this RTCC. Now let's try with get weather. Wow, we have the temperature, pressure, and altitude and humidity parameters. This is the reason also because this sensor is very popular. Now this one was command. This was a query command. Just retrieve data of this sensor and clock. That means that the data arrives by the serial communication protocols, and once this reach the SP32, then the SP32 brings the data using the local communication protocol, I2C in this case. Now let's test for setting the position of the servo motor. Command name set servo, and the parameter is angle 2. Let's test with 90. Wow, 90, it moves. Servo position set to 90. Now let's test with 180. And let's test with 1. Works! You can use a command for setting the position of a peripheral, in this case a servo motor. Will it work with a LED? Let's see. Let's test turn. The name is turn, yes, turn LED. Turn LED. Color. In this case, let's start with the red. And the on-off parameter. Yes, this is the name, on-off, yes. You can see the names here because you set it properly. On-off, it's equal to 1. Remember that it's a Boolean variable. You can set as a 1, true. Look, it's turning on. You can turn on using 0. You can turn on using also true. And you can turn it off also with false. Boolean data type supports the uppercase, lowercase because I am improved that in my library. Now let's test with true. But now let's change to the green LED. No, we need to put the proper name. In this case, green in lowercase. Turns 0, turn off. As you can see, you can turn on and turn off peripherals using the command line interface, and you can retrieve data and information. So, as you can appreciate it, I made a command line interface for convert any embedded system into a professional command line interface. That means that you can retrieve information of the sensor more professionally, and also it's more intuitive because the commands are very easy to use. That means that anyone can understand the command get weather and get time instead of just sending any characters and just retrieving any information. This one will help you in your new project that you are developing. I appreciate your attention, guys, and I wish you a nice one. See you in the next videos of the embedded systems.